Hello everybody, I hope you're doing well. We're going to start studying conic sections in this unit. So there are four that we're going to study, parabolas, and then our next lesson will be circles and ellipses together, and our last one will be hyperbolas. So generally I do a little more explanation about why we call them conic sections, but given the circumstances we're just going to boil it down to what's going on and what are we dealing with. Step one is we're working with parabolas for our first lesson. Now, our normal parabolas we've been working with up to now have been vertically oriented parabolas. They look like this. However, they can be horizontally oriented. Furthermore, we kind of draw them generically, but they could be more flattened out or more narrowly opening like this. So this is kind of like a standard look, but they can come in different shapes and sizes like this. So one thing we have to lock down first is the anatomy of a parabola, because when we get the equations, the whole point is the equation tells us what the picture will look like. So what is it that's in every parabola, the anatomy of a parabola? Every parabola has what's called a vertex. The vertex is like the turnaround point. One thing we don't see in other classes, actually I should be careful where I write that V. Let me fix those. I should do it a little off to the side so I leave room for the other body parts. So those are good. So one thing you probably haven't seen about parabolas is something called a focus and a directrix. So a focus is a dot right above or below or to the left or to the right of the vertex. This line right here, this would be called an axis of symmetry because it looks the same up top and below it, like it's reflected around it. This would be the focus. This would be the focus. So the focus and the vertex are on the same axis of symmetry. So what is the focus? Well, you don't need to know this, but this is just very helpful. If you have a house with a satellite dish on it, this is actually called a paraboloid, the dish itself. If you were to take a saw and cut it right down the middle, you'd be seeing a parabola. And you know how there's a little like boom right there on every satellite dish? There's an arm sticking out with something like a piece of electronics right in the middle of the dish. That is right at the focus, because what a parabola does is anything that comes in and hits that parabola bounces towards the focus. That's why it's called the focus. Right? So things would come up and go to that focus. No matter where it comes in, it would be reflected to the focus. Now, you don't have to know that. We're not going to be actually using that, but that's what it is and why it's significant. And it's going to be in the same axis of symmetry, right above, right below, to the left or the right of the vertex. Now, even weirder is going to be something called a directrix. So I'll just draw them and then explain them in a minute. So this would be the directrix. This one would be here. And this one would be maybe here. So, and there are horizontal or vertical lines in these cases. So the way I like to describe it is the focus is inside the dish. If the parabola is a dish, the focus is inside the dish, and the directrix is outside the dish. So you kind of see how it's oriented. Now, one of the things we're going to care about is the distance from the vertex to the focus. It turns out, here, let me get rid of this. The focus and the directrix are the same distance from the vertex. It's just they're on either side of each other, or the vertex is right in the middle. And we call that distance is P. We use the variable P for that. So this would be P units up and P units down. So if it was 1 up, it'd be 1 down. If it was 2 up, it'd be 2 down. if this is half a unit to this focus, it's half a unit to the Directrix, and I would call that 1/2, like P equals 1/2 if that was a half. If this was like 5 units, oh, I didn't draw this very well, did I? So however far that is, the vertex should be right in between the focus and the Directrix. So step 1 is, what are the body parts? There is the vertex, the most important point. Then you have a focus, which kind of makes sense because it's inside the dish. We have the Directrix, which is weird because it's just some line outside the parabola. And then we have this variable P that we're saying is, that is how far, that is, look, here, this is P, how far that is. This is P, this is P, this is P, however many units those are. Now I know that's probably weird, but if that's true, let's look at the equation. So the way I set up the board is there's 2 different equations. There's one equation, they're similar to each other, for the vertically oriented and one for the horizontally oriented. So the vertically oriented looks like this. X minus h squared equals 4p y minus k. And I'm gonna talk about that. I'm gonna unpack it. To make sense of what we're seeing, we have to look at one example, not 4 examples, and see what's going on. But for right now, let's get that equation in place. So this is vertically oriented, x stuff squared. Horizontally looks like this. Y minus k equals 4p x minus h, and that's squared. So the horizontally oriented ones, the y stuff is squared. For the vertically oriented ones, the x stuff is squared. There's the formulas, so now I have to erase, and we're going to pick these apart. I'll start with this one, and I'll show you how that equation relates to the picture and what all the parts mean. All right. All right, so let's start with the equation. So if I have x minus h squared equals 4p y minus k. Now let's throw some numbers in here. X minus 2 squared equals 4 times 3 y minus 1. So notice what I've done is I put a number in for the h, the p, and the k, so they're numbers. Notice that the y and the x are still in the problem. Now really you wouldn't see it like this. The way you would see it in a book or on a test is this would just say 12. And we just have to realize, well, if I'm seeing a 12 there, then p must be 3 in order to equal that 12, right? You just kind of like figure it out. We could calculate it on the side, but usually you do not show this middle step. So this would be my equation. What is this equation telling me? First of all, this number, do not worry about like that's a h and that's a k and what does that mean. This is what that number is. This is the x coordinate of the vertex, but you've got to switch the sign. That's why it's minus instead of plus. This is the y coordinate, specifically that 1 of the vertex, but you got to switch the sign. And this, the 3, is the distance from the vertex to the focus, or Directrix. I'll put DIR. Whenever I put DIR, sorry about that. Whenever I put DIR in this particular unit, that's Directrix. So here's our equation. K is 1, H is 2. I'm not worried about the minuses right now. That P must have been 3 to give me a 12. And this is what all these things mean. So I got to erase the notes part. So what this is telling me is that this, first of all, is a vertically oriented parabola. Why? Because it's x squared equals y. That tells me it opens up or down. It's vertically oriented. Second, it tells me that the vertex is located at 2, 1. This is the x coordinate, but you got to switch the sign. This is the y coordinate, but you got to switch the sign. See, the vertex, I just pull it right out of the equation after I get used to this and see what's going on. P has to be 3. P would have to be 3 in order for 4 times something to equal 12. Now the last piece is this happens to open up. So, how am I going to put this? If P is positive, if this number in this spot right here in the equation is positive, it opens up, or I'll put it opens in the positive direction. I need more space. We're going to have to swing back and hit that. For right now, I'm just going to say it's vertically oriented because it's x squared stuff. And I'm going to say it opens up. And right now you wouldn't know why. I'm going to come back and explain that after but I got to erase the board. So right now, take my word for it. It opens up. So how do I put these pieces together? At the end of the day, you got to graph it. You'll be given this equation. The directions are graph it. So I need my graph. And I know I have a vertex at 2, 1. So there's my vertex. See, now I got to know, how does this open? It could open up, could open down, could open left, right, could open left. I don't know. That's why I have to notice that when this is x squared, it's up or down. And I'm going to tell you how I knew it was up in just a minute. So I know that this has to be the bottom of the parabola. So it's got to open up. Now I'm not going to care right now about how wide it is. Excuse me. You have to put the focus and the vertex in. Well, what does P tell you? P is how far from the vertex the focus is. And the focus is in the dish. So in this case, if this is 1 unit up, 2, 3, 4, 3 units above that will be my focus. And 3 units below that will be my directrix. So your job is going to be to draw what I'm drawing. We got to scale our axes. 1, 2, 1, 2. So I'm going to be looking, do you have a vertex? And did you put a V by it? Do you have a focus in the right spot? Do you have an F by it? And did you put the line, the directrix, in the right place? So now I got to explain how I knew it opened up. So I got to erase all this before I can even do another example to make one more follow-up point just on how it opens. How the parabola opens. Well, if it's vertically oriented, then I'm going to have this equation. And if it's horizontally oriented, I'll have this equation. Now, if this number is positive, if I have x minus 2 squared equals 8 y minus k, y minus, we'll put a number there, versus x minus 2 equals 8 y minus 3, but there's a negative there. See, it could be 8 or negative 8. Now let's do the same thing here. So it's important for you to notice the only difference is the fact that this is negative. Otherwise, they're identical. If this is positive, if this number is positive, this opens up and this opens right. This one opens down and this one opens left. Now, one way to learn this is to memorize it. I hope I haven't been blocking this part of the screen. One way to do this is to memorize it, but if you just think about a coordinate axis, if you have, see how these are positive? What are the positive directions? If you're talking vertically, isn't positive up? Positive is up. And if you're talking the x-axis, aren't the positives over here? So positive is right. Whereas if I'm talking about up and down, the y-axis, negatives are down. So if it's negative, it's down. And aren't negatives back here on the left on the x-axis? So a negative would open left. Right? So if it's horizontal, positive is right, negative is left. If it's vertical, positive is up, negative is down. All right, we're going to need to try another example. Let's do an example of a horizontally oriented parabola that opens backwards to the left. All right, so let's say I have y plus 1 squared equals negative 4 x minus 3. So I look at it, and it looks like a parabola equation. First thing I can tell is the vertex, the x number is the x coordinate, switch the sign. The y number is the y coordinate, switch the sign. So I know where the vertex is. What would p have to be? Well, you can write negative 1 if you want. Think about it. 4p is normally in this position in the main equation. So what would p have to be to make that a minus 4? You could put minus 1 if you want. 1 is what we care about. 1 unit. 1 unit. Because that's how far it is to the focus. So I really care about the 1. I don't really care about the minus. All right. Furthermore, it's y squared, so I know that that's either up or down. And because I see that minus, I know it opens down. So it's going to be a vertically oriented parabola, up or down. Specifically down because of the minus. I know where the vertex is, and I know how far it is to the focus and directrix. So those are the puzzle pieces. Now we have to put this into play. So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. So I have a vertex at 3 minus 1. I know it's, whoa, back it up. Horizontally oriented is left or right. My bad. Some of you are probably wondering what the heck I was talking about. Horizontally oriented is one of these directions, and minus is this one. So it's going to open backwards. So from this vertex, it opens backwards. My focus is inside the dish. How deep into it? 1 unit. So I'm going to go 1 unit back, right? I could think of that minus as back. But the directrix is going to be 1 unit on the other side. So if that's at 3, that's at the 4. So that's directrix, focus, vertex. And there's our second example. So now I'm just going to do, like, I don't know, we'll do 3 or 4 more examples so you can see what's going on. And for your homework and for the test, your job is to be able to take an equation and give the graph. Let's see if I can fit two examples at a time. All right, let's do y minus 3 squared is minus 20x plus 2. And x plus 1 squared is 12 times y minus 2. Alright, now when I look at this, the first thing I like to get out of the way is which way does this open? Horizontally opened, y squared. Negative, so which way is negative horizontal? That way. So this is going to open left. The vertex is at negative 2, x with x, positive 3, y with y, switch both the signs. And the p-value, what would I have to have there that would make that be 20? Well, normally, like in the equation, it's 4p, so that's got to be 5. Minus 5 if you want, but the big deal is it's 5 units, okay? So now we're going to graph this. 1, 2, 3, 4, 5, 6, 7, 8. Got to give a little more room if that p-value is 5. Going by ones here. So I have a vertex at minus 2, 3. I know it opens backwards. And the focus has to be 5 units inside of the dish. So if this is at 2, 1, 2, 3, 4, 5. And the Directrix is 5 units on the other side. 1, 2, 3, 4, 5. So line right here. Let's go again. X squared. That's vertically oriented. That's positive, so it opens up. Furthermore, there is a vertex at negative 1, comma 2. And also, the p-value would have to be 3, because 3 times 4 would equal 12. So now I'm going to graph it. I have a vertex at negative 1, 2. This opens up. Then the focus will be 3 units inside the dish. And the Directrix will be 3 units on the other side. So notice, if you have all this information, it's really not bad. You're just pulling the information out of the graph, and that just takes time and practice. So if you practice these and do the homework and you're playing it out, you'll get more and more comfortable with this. But let's do a couple more examples. These are going to look different. They're not really. I just want to show you how to interpret them. And then we'll tie it up and you can start practicing. All right, we'll do 2 more examples. So you can see why I want to do these. These look completely different. So this is how you want to view these. See how I'm not seeing parentheses? When it just says X or Y, this is what's going on. It's because those are zeros that are with that. So in this case, this is how it's supposed to look. Why does it look like that? Because if these were zeros, you would, what is x minus 0? It's just x. See, that's why it collapses down that. It looks different because there are zeros. So if it helps, I would actually write that out, because now, let's see what we see. X squared stuff that's vertically oriented, that's positive, so it opens up. The vertex is at 0, 0. And the p-value, 4 times what would give you 16? P-value's got to be 4. 1, 2, 3, 4, 5. So I have a vertex right smack on the origin. I know that it opens up. And I know that the distance to the focus is 4 units inside the dish. And the Directrix would have to be down here on the 4 units. Okay, last one here. Why stuff is squared that is horizontally oriented? It's negative, so the negative horizontal direction, it opens that way. The vertex is at the origin for this one also, 0, 0. And the p-value, what would p have to be so that 4 times it equals 2? Well, p would have to be a half, right? 4 times a half would give me 2. I understand that can be a little bit weird, but hopefully that makes sense when you hear it. Alright, so here we go. 1, 2, 1, 2. We have a vertex at the origin again, but this time it opens sideways like this. And now the focus is very tight inside there. It's just half a unit in, and the Directrix is half a unit out. So this is Directrix. Don't forget to put your labels V, F, and DIR. Okay, give those a shot, and you're going to find out that our other types are circles, ellipses, and hyperbolas. If you get what's going on here, there's a lot of similarities. All right.